Okay, AP test problem. 13 is first. We are given a function that's defined by f of x from 2 if x is greater than 3, or x minus 1 if it's... What? No, I'm on the right one. If x is less than 3, we have 2. If it's greater than or equal to 3, then it's represented by x minus 1. That's the problem we're doing. Yeah, I was told to wear green. Everyone thought we were wearing red for some reason today. Yeah, right? Yeah. So I don't think people remembered. Okay. What is the value of this integral? Okay. We need to split this into two different integrals at this point, because the balance is different. Our first, we good? Yeah. What should you split up to? We're doing 13. This is the first one you guys wanted to go with. So balance first. We have to split this into two different ones. So 5 to 3. What is our function from 5 to 3? 2. Yep. And then dx. Plus my rest of my balance. So it should go from 3 to 1. And what is my function from 3 to 1? X minus 1 dx. So on our problem, it gives us that from f of x equals 2 when x is less than 3. Yeah, I also think that too. Switch them. My bad. So, from 3 to 1, we have 2 dx plus the other integral of 3 to 5 x plus 1 dx. Sorry, that is it. Yes. Okay. Take the antiderivative of 2. What is it? 2x. We gotta go from 3 to 1. Plus, what is the antiderivative of x plus 1? Yeah. Plus x. Is this whole problem -1? And no one told me.
Oh, what is x minus 1?
Yeah. It should be negative. I'm sorry. That's what the function was when they stated it in the problem. Oh my god. I'm looking at a paper and I'm looking down. Okay, there we go. This should be from 5 to 3. Okay, did we get to this point in our work? Yeah, okay. Then we just plug in. So this is 6 minus 2 plus whatever this is over here. So that's 10. No, that's not 10. That's 25 over 3 minus 5 minus, we have 9 over 2 minus 3. And when we simplify that, it should equal 10. Yeah. So this is 4. I don't really want to simplify this. But yeah, so this would be down to 4. 5 times 3 is 15, so that should be 10 over 3 minus, that's 6, so that should be 3 over 2. Yeah. That should be 4 plus whatever that fraction is. So 6, probably. Do you want me to walk you through the math of that? Okay. I could do it off the side, but equals 10. Yeah. Equals 10. That was 13. Good?
Yeah.
Okay. Next one was 21. Gotta say, limits aren't my best friend. Okay, the line y equals 5 is a horizontal asymptote in the graph of which of the following functions? Oh, okay. How do we find horizontal asymptotes? Yes, in our first one, we can't really use that. Well, what would the first one be? We can also do the limits. So what is the limit of x as it approaches infinity of sine of 5x over x? I wasn't here when you all did limits. How did you approach these problems? Plug it in? What did you plug in? Okay. If you plug in infinity, what do you get?
Then if it doesn't work, you have to
Factor it?
something to cancel out.
Do you remember?
Oh, and then if you
Yeah, but if it's infinity over infinity, we have to do, so L'Hopital's. Yeah. And we take the derivative of it. Yeah. So that, what would the derivative of this be? Over 1, right? Okay, so cosine and the x goes on. When does it ever stop? It's supposed to be 0. It's supposed to equal 0. Limits have been, I haven't really done limits in a long time. You can do L'Hopital's with this, definitely. And you get 5 cosine, and then 1, the x just becomes the 1. Mm-hmm. Not helpful for this. It's not that one. We're trying to find where it gets to 5. Has a asymptote of 5. Okay, well, that one's supposed to go to 0. That's not really helping you. But limit of the next one, which is 5x. Okay. If I go, this is just a linear line, right? This one definitely just goes to infinity forever. As I go to infinity, the x values, the y values are going to infinity. Mm-hmm. The next one, so I have limit of x going to infinity. So I'm still thinking about the first one. 1 over x minus 5. Sean, what were you saying? Yep. This one is 0. Okay, last one. Limit of x as it approaches 0 of 5x over 1 minus x. Well, we kind of, 5x. No, that's right, yeah. Top one goes into to infinity. What happens about the bottom one? Sadly, no. It is not. So, yes, that negative infinity is an important point in this. The answer to this one is -5. Negative. To the highest power. Oh, the take the leading coefficient, so it's 5 over the -1, which is just -5. Yeah, I forgot about that. I like those. Okay, limit of x. We still have not found any that equals just regular old 5. We have 20x squared minus x all over 1 minus 4x squared. I'm going to scooch down. Okay, what can I do first? That would help. So we have 20 over 4 now. What does that equal? 5. So that is our answer. So that's my leading coefficient of the largest x value term. So these are all x squared and x squared. So I take the number out front of those two. Okay. 21 is done. 22. Let f be the function by f of x equals ln of x over x. What is the absolute maximum value of f? Oh. Ugly. Okay. So, we have f of x equals ln of x over x. We want to find the absolute max of regular f. Angel, how did you start this problem? What? What's the derivative of this function? Not. What did you do? What property? Quotient. Yep. Do you want to do step-by-step quotient? What did you get at the end? B's right. Yeah. So take your bottom function. No. Sing. I want to hear the chorus. I'm glad that's on the video for your friends. Minus ln of x. Okay, then what's the bottom? No, in the song. Low. I'm trying to see, like, in the song, what would it be? I love how you all go deep with that, too. Yup. Boom. Oh, okay. That's what we have. This simplifies to 1 minus ln of x over x squared. Okay. What does that equal? Well, we want to set it equal to 0. Yep. Yeah. So 0 times x squared, well, that's just 0. So then we can subtract ln of x from both sides. So we have 1 minus ln of x. So what would x have to be for this? Okay, if you don't know the answer to this one on top of your head, I can change it to a what type of function?
Yeah.
So it is a log base e right now. Change it into what form? Exponential form. Yep. So this would just be e to the 1 equals x. Yep. So x should just be e. Yeah, it should just be e. We're not done though. It's 1 over e. Why is it 1 over e? For the absolute maximum. So f of x is now f of e equals ln of e over e. And we know that ln of e is 1 over e. Boom. Okay, that was 22. Our next one is 27. Oh, that looks ugly. 27. You have x plus 2y times d of y over d of x equals 2x minus y. What is the value of the... Yeah, so I'm just going to call it second antiderivative at 3, 0. Lovely. Okay, so let's start with our function. This is our function. We gotta move some stuff. What should we move? Yep, divide this and move it over to that side. So 2x minus y over x plus 2y. And guess what song? We get to all sing again. Minus Heidi Love. That's funny. So 2 minus dy over dx minus 2x minus y. This is the second one. All over 1 plus 2 dy over dx. All over the same thing in the bottom square. Okay. Yeah. This is the second one already. So this is x over dy of x. That's what this all equals to. Two x minus y. 1 plus 2 this. 1 over here. Beginning. So take your bottom, put it over. Take this one up here. We have the x cancels out, and then we have dy over dx. So I'm taking the y, and that becomes dy over dx. Okay. Next step, I have from 3 to 0. So what do I need to do? Are you sure? Yeah. Yeah, what's the value? So we got 2 over 2 times 3 minus 0 over 3 plus 2 times 0 equals 6 over 3, which equals 2. Boom. Now I can plug it all in. to this entire equation. I'm going to do it in a different color. What's... right here? Want to go back here? Yeah, plug this guy into dy over dx, the original function. Make it that's 2. So that if this function on this side equals 2, that means dy over dx equals 2. So I can plug in it up there. So I have 3 plus 2 times 0. Oh, this is a lot. 2 minus 2 minus 2 times 3 minus 0. And then 1 plus 2 times 2, all over 3 plus 2 times 0 squared. Okay. That should equal, well, we'll just do it. 3 times 0 minus 6. This is 5 all over 0, 6, 9. So negative 30 over 9. So I plugged it in, all my values, my 3, my 0, and my 2, to the values up top, and we should have gotten negative 30 over 9. Negative 30 over 9? Yeah. Is that what you got? We're not done yet. Oh, yeah. Okay. We want to simplify so bad. What do you get? Yeah. Top part is ugly, but it makes a very nice number at the bottom. Oh my god, totally. Yeah. We're looking at 28, and I need more of it. 28. For t is greater than 0, the position of a particle moving along the x-axis is given by sine of t minus cosine of t. What is the acceleration of the particle at the point where the velocity is first equal to 0? Oh, okay. That was great. Okay. 28. My original function is this, sine of t minus cosine of t. That is our original function. What do we have to do to our function? Take the derivative. What's the derivative of sine?
Cos.
And, no, cosine. Yeah, don't say cos.
Oh.
Sorry, I like geometry people. I have to like be like, no. Don't say cos. Okay, cosine. What is the derivative? Negative sine. So we should have positive sine here. Okay, I'm not done. I'm only at velocity. I need to go.
Acceleration.
Yes. I need to go again. Okay, cosine. Negative sine. Plus cosine of t.
You know what? You guys do it. No, I heard it too. What is it?
Okay, we got a fact that the velocity is equal to 0. What is the acceleration of the particle at the point where the velocity is equal to 0? So you have to take a velocity. Equal it to 0. Okay, I'm gonna move something over. Let's move sine. I don't think it really matters which one you truly move over. So negative sine of t equals cosine of t. Ooh. Okay. We need to figure out when these two are equal. What? Is there identity that we can use? Why fourth quadrant? Very true.
Probably still with like the 1 root 2 over 2 because those ones are the same.
So we're in denominator of 4. That's what we're talking about. T has to be greater than 0. That's the problem in that. T has to be greater than 0. T is our x or y value, technically. I think that's going to help us. That is true. I don't think it's going to help us. I'm thinking of graphing this. Sorry, I'm thinking of graphing this. Sean, you can do it. So, I'm going to graph sine and what? That's true. Okay, the answer to this should be 3 pi fourths. I think they got that, Sean, because I agree with you. They did negative cosine of x equals sine of t. So then we're in quadrant 2, right? Then we're in quadrant 2. Because that's when sine's positive and cosine is negative. So, and this is in quadrant 2. Yeah. I'm not 100% sure if I switched it, if